Hello, everyone. Thank you for taking the time, especially at the end of a long day, to meet with us. And so I'm going to talk to you about all of the things that we're doing in machine learning and tell you a little bit about kind of starting with how we've approached our journey with machine learning, and then tell you a little bit about how we're trying to help you with the tools that we're providing with Google Cloud, and show you some of the interesting things that we're doing and some of what our customers are doing as well. So the first thing is, we as Google talk about us being an AI-first company, and it is much more than a marketing shtick. It's actually a real thing, and I want to give you a little bit of the insight behind that. And so we've been doing things in machine learning for a long time, but where it's really taken off is over the course of the last 4 to 5 years. And what you're seeing here on the screen in the graph is these are the number of projects at Google that have a deep learning model in them right now. And so you can see that going back to 2014, there weren't very many that were there. But then over time, it's increased exponentially to the point where this is as of last year, we had 7,500 projects that had machine learning models in them. And we've gone from just a few products using this to almost every single product using this. So things that you wouldn't expect. In your Android phone, for example, the battery is optimized via machine learning. We look at things like malware in the Play Store via machine learning. We use it for recommendations in YouTube. We use it for controlling the pen in Chrome OS. Things like that you wouldn't expect it to be. And what we're finding is that almost every business problem that we have, there are ways that we can apply machine learning to help solve those problems. So it's really become a computing paradigm for us. And so part of what we're trying to figure out is how can we use our advantage here and kind of the experiences that we've gone through to help our customers as they explore their journey with machine learning. One of the biggest problems, I talked about this morning, is just the sheer level of talent that's out there that can actually use machine learning. And this is what we're seeing in the market, that there are only about tens of thousands of developers out there that can successfully build a deep learning model. They're probably on the order of, this says 1 million, probably 2 million data scientists that are out there. But there are 21 million developers, and there are 200 million knowledge workers. All of them should be able to use machine learning, but they can't really right now. So we want to figure out how do we make it such that that is possible. And we need to make AI more accessible in order for people to really use it effectively to solve their problems. So the goal of our group and what we've really focused on is how do we democratize AI by making it easy, fast, and useful for customers and partners. Easy such that it's easy not only for the novice, but also for the expert. We can make it easy across the board. Fast such that Google Cloud becomes the fastest place for you to run AI, but more importantly, the faster that we get, the more things that are possible. And we feel that you'll see the same thing that you saw with Moore's Law, that as chips got faster and faster, more things became possible and computing became better. And then we think the same thing is going to happen with AI. And then useful. There are a lot of things that AI can do that are very, very cool. But what we're really focused on is how do we actually do things that are very useful for you, that are solving critical business problems. And that's a real crucial thing for this. So some of the things that we've seen our customers do with AI kind of fall into these 4 categories. One big area is around personalized customer interactions. And this is everything from, can you use machine learning to automate how you answer a phone call and make that experience better for a customer, all the way through to things like recommendations and various other things to make the customer experience better. Can we make it such that you can really get closer to your customer as a result of machine learning? Ocado is a great example, and I'll talk about them a couple of times here, but one example I thought was interesting is that they are using natural language understanding to be able to understand sentiment of incoming email messages. All of us have had that experience where we send an angry email to a company, but we don't hear back from it. They're using this to understand if an email is actually angry or not, and then escalate it through the right path as a result of that. Efficiency and agility. We see this in a lot of different places. We use it, for example, within our data centers, but then we're seeing this in the industry in everything from optimization of controls all the way through to optimization of processes. And so there's a lot that AI can do to make things efficient. Spotting patterns. This is something that AI can be very good at, and spot patterns where humans don't see patterns. An example of this is Rolls-Royce Marine, where they're using it to spot obstacles in a marine, in an oceanway or a waterway that typically humans may not be able to spot, and that makes it so that it's a safer route for their ships. And then adding structure to unstructured data is a big part of this. How can we actually make it so that you can take things that are unstructured, but make it so that you can make decisions on it like you do with structured data? Box is a great example where they've integrated things like our vision APIs to make it so that a person has more information about their images. But then there are a plethora of examples here that we're seeing within the industry. And a lot of things fall into these 4 categories. So we're focusing on 4 ways that we can actually make Google best for you for AI. The first is scale, which is, of course, the scale of Google Cloud. And this is the reason why we've been able to make so much use of this within Google, as just the scale of data, the scale of compute is such that our models can get better and better and better. The second, though, is speed. And this is an interesting one because what we've had to do is really rethink our data center infrastructure as a result of AI. And this started at the hardware level with TPUs. I think what we were realizing a few years ago is that if we didn't do something like that, we would actually be tapped out of capacity because of the increased workload from machine learning. And so this is how we rethought our infrastructure to make it optimized for AI. Quality. A lot of this boils down to quality. AI has been around for a long time. And part of what has really changed over the last few years, especially for unstructured data, is the quality of predictions has become very, very good. And so that's something that we're really focused on, using a lot of the head start that we have with what we call these pre-trained building blocks that I'll tell you about a little bit. And the last thing is customization. How do we make it so that you're able to customize this to your business problem without having to know all the skills necessary to do custom models? And so that's a tricky part. This is where I think the rubber hits the road. So for example, if you're using something like vision, if you're using a very generic model, you may be able to tell the difference between a dog and a cat. But that probably is not going to be exactly what you want to do for your business problem. And so customization is key. We have kind of 4 key layers of the stack that address this, and then 4 key audiences that we're trying to address as well. So at the bottom of this is our data and analytics stack, which you heard about in the last session, that is underlying all of this. But then on top of that, we have an AI platform that makes it so that you can scale building models, training models, and deploying models in a very easy way on Google Cloud. The second part of this are those AI building blocks. And what we've done here is we've looked and tried to bring together the best of Google's models. So for example, we pulled together models that we've refined over for image recognition across many different Google products, or for video intelligence across many different Google products. Things like speech-to-text and text-to-speech that we refined for things like Google Assistant. And we now bring those as services to you that you can use for your own applications. And the last part are AI solutions. Specific business problems that we can solve in conjunction with partners that make it so that this is actually useful for key business problems for you. And there are really 4 different audiences. One are those business users. And I think a lot of companies that we talk to, one of their biggest questions is, where can AI be the most effective? And this is where we're trying to work with partners to show the way in terms of where this can be the most effective. A second one is data scientists, and I'll talk a little bit about Kaggle a little bit later, but Kaggle is a really remarkable organization that they have a community of over 2 million data scientists at this point. And one thing that's great with this is that with this, we have a way by which we can actually reach data scientists, but then also help people become data scientists as well. The third is developers, and so we're trying to integrate this more and more with Google's developer tools to make it accessible to more people. And the last is end users. End users should be able to access AI through things like spreadsheets, but then they should also be able to make their productivity better as a result of AI, and we're doing that through G Suite. So when we look at the building blocks, there are three big areas that we've been focusing on, which is sight, language, and conversation. Sight includes things like images and video. Language includes things like translation and natural language understanding. And then conversation takes a lot of what we built for things like Google Assistant, as I mentioned, with speech to text, text to speech, and then also understanding intent and answering questions such that you can build your own infrastructures based on that with Dialogflow. But as we talked about before, customization is key. AI is a mass customization problem, and even if you have the same problem as somebody else, likely you'll need a different model. So how can we make that easy for you? So what we've done is we've built a way by which we can take a data set and then we can use machine learning to find the optimal model for that data set and iterate and find a better model over time for that data set, and then deploy it instantly into production. So we could take, for example, a set of images, find the right model for those images to give you a highly accurate model, and then make it so that you can just use it via an API and don't have to think of the productionization. This has really opened up the type of user that can use this. And we've been amazed to see the effect of this. We now have this for vision, for natural language, and for translation. And we've seen tens of thousands of users and companies start to use this for problems that we wouldn't have even dreamed of. And so we're getting AI to be closer to the subject matter expert of a business with this. And so I'd like to welcome up Satish, who's going to show you this this demo, and I'm going to kind of guide you through what this actually looks like. So if we can switch to the demo, please. There we go. Okay, so what you're seeing on the screen is the interface for Cloud AutoML Vision, and what this shows you is an example with leaves. And so you can imagine there are all kinds of different leaves that are out there that all look fairly similar to each other. But then can we build a machine learning model that makes this makes it so that you can find one from another? And so the interface here, what you're seeing here is that you can bring in images much like you would in, say, something like Google Photos. But you can pull from your other Google Cloud properties, from things like GCS, or upload it directly here. You can see how many images you have per label on the side. And then once you have your data set, you can go train it. Another thing that we put in here is that you're able to actually we can label those images for you. We have a labeling service that's included as a part of this, and so if you want images labeled, we can actually label it for you the same way that we do that for a lot of images at Google. The next part is that you go to the Train tab, and you can push the button to say Train a new model, and we'll find the right model for you. And what you can see is that we've created a couple of models here, and we can get to very, very high accuracy. You can see that we're getting to precision of about 99.4%, or sorry, 98% and 99% on these two different models. But one of the key things there is that that's good to kind of get that high level, but then you want to be able to iterate on that model and figure out where is the model failing. And so if you go to the full evaluation with this, you can start to see ways to actually take a look at this. So we provide graphs, but I think one of the things that has been very popular about this is this confusion matrix. So you can see where the model is actually tripping up and where it's failing. So you can see, for example, in the case of that first row, about 11% of the images from the test data set are getting classified incorrectly. When you click into one of those, you'll be able to actually see the images where there are false positives and false negatives, and then be able to kind of see why it's getting confused. And it'll also show you where you need to add more data to make the model better and better. So once you've done this, the great thing is that it's already then deployed on Google Cloud. And you have a variety of options of how to actually test it. You can try it with images that you upload directly here, or you'll just have a REST API. You can take that code snippet, put it into your application, and you're done. And that is all that you need to develop a custom model. And so you can see that Satish is adding a couple of images in here, and it will actually run that through the model and be able to test this. And so this takes care of all of the parts of the process, everything from model creation all the way through to deployment of the model, and makes it easy to do. And you can see in this one, it's able to actually predict it quite accurately. Can we go back to the presentation, please? Great. So one layer below that is that if you're able to go and create models yourself, we want to make those easy to create and easy to deploy. And so this is where our Cloud AI platform comes in. We want to make it so that you can do fast prototyping. So for example, in things like BigQuery, being able to build simple models and start to use them there, and then also set up the data exploration to figure out what data is going to be needed for your model. We want to make it so that you have easy model management, so that you can easily train a model, test a model, and then put it into production using our tools. We want to make hybrid really easy. We understand for sure that there are going to be some things you want to deploy in the cloud. There might be some things that you want to deploy on-premise, and you may want to go back and forth on that. And so we focused on hybrid deployments. And we want to make it multi-framework. And so we have TensorFlow, but we also have the ability to do things like scikit-learn, XGBoost, and we just announced the support for PyTorch as well. And so you're going to see us add more and more model frameworks into this as well. And where our goals are is that we want to make it really easy for you to train the model and do things like, for example, hyperparameter tuning to make sure that so that you can train it in an optimal way. We want to make it easy to deploy the model and take it from a test model through to production, and make it so that you can integrate it easily into your applications, either for real-time predictions or batch predictions. We want to make it easy for you to share that work. One of the powerful things we believe is that if you've created a model, others should be able to use it within your company, for example. And so we want to make it easy to share. And then the last thing is we want to make it easy to deploy anywhere. So in terms of that kind of flexibility, we have Cloud ML Engine, which lets you have flexibility in terms of the models or the models and frameworks that are there. And this makes it so that you can easily create and deploy things on Google Cloud. But one thing that we've recently been working on is what we call Kubeflow. Kubeflow is an open source project, which is essentially a machine learning framework built on top of Kubernetes. And it makes it easy to deploy machine learning on top of Kubernetes. This is something we've been continually iterating on with the industry, and we just released version 0.3 with this. And this gives you an easy way to do multi-cloud operation. As anywhere that runs Kubernetes, you can run Kubeflow. And if you build something using Kubeflow in our cloud, you can move that model and the entire production stack somewhere else if need be. And so some of the things that Kubeflow really provides is that it's very easy to get started with Kubeflow. You have out-of-the-box support of a lot of these top frameworks, and then it's built on top of Kubernetes so that all the things that you do to manage your Kubernetes clusters, you can use for this as well. It's swappable and scalable. There are a whole library of ML services that you can start to use, as well as support for different accelerators. And then it meets you where you are. You can use it in multiple clouds. You can use it in our cloud or other clouds or on-premise. So last on the thing here is, but how do you get access to data scientists? So what if you could hire 2 million data scientists? So I talked about Kaggle and the Kaggle community of 2 million data scientists. One interesting thing we have with Kaggle, and what Kaggle was based on or founded on, was this concept of competitions, where a company could put up a competition on Kaggle and then have data scientists actually try to solve that. And we've seen some really interesting examples of competitions where companies were able to solve really crucial problems using the community. And we think this is another big area where we can make it so that people are able to bridge that talent gap and utilize experts that are out there with Kaggle. The other thing about Kaggle is that we really look at Kaggle as the place to go to both learn and do data science. So we provide a lot of tools for people to be able to start to learn data science, and then tools for them to be able to use it. Great notebook products, for example, public data sets and public models by which they can actually start to use machine learning in interesting ways. Underneath all of this is our infrastructure for doing this, and this is where we're really expanding the frontier for performance with what we're doing with TPUs. And this is something that we've done iteratively over time and have gotten better and better and better at it. So last year we introduced, earlier this year we introduced TPU v2, which is essentially designed to have very fast performance for very specific types of machine learning workloads. For example, things like image recognition run very well on this. Language type tasks like translation and NLU run very well on this. But we just introduced the beta of TPU v3, which you can see is quite a bit faster and really kind of sets a new bar in terms of those specific tasks. And really what the insight here is that we realize if we design the chips for specific types of workloads, we can speed up those workloads very significantly. Another interesting part is the TPU pod. And what this is a variety of, or a bunch of TPUs tied together through high-speed interconnects. And this makes it so that you can run very, very large tasks. And so for people that are running very large machine learning tasks, it gives you unparalleled performance. Last part, though, is then the solutions. And I think one thing we're realizing is that a lot of models that get created actually never get used. And the problem is that to make it useful, you have to integrate it with your enterprise data, but you also have to integrate it into the workflow that your users are using. And so the combination of that data and workflow along with our models really introduces these powerful AI solutions. And so that's where we're really focused. How can we infuse our AI into your existing workflows? So a couple of examples of things that we just released around this. One is contact center AI. I'm sure all of you have had this experience where you pick up a phone and you dial an 800 number and you get a horrible experience. If you're like me, you start hitting 0 as quickly as you can to try to get to an agent. But what if we can make that experience a lot better? What if we can make it so that you're able to get simple questions answered very quickly in an automated voice manner? But then what if we can make the agent's life easier, such that they have the right information when you're transferred to an agent. They're only transferred at the right time where something automated can't answer it. And they have information by which to help answer those questions as well. So that's what contact center AI is. It brings together a lot of the speech technologies, the conversation technologies, and natural language understanding to make this possible. But you're already using a variety of tools out there for your contact center. And Google is not a contact center company. So what we've done is we've partnered with all of the leading providers of contact centers in the industry and infused this technology into their products. So when you're using a particular product, now that is now a part of that product. And so you don't have to change your workflow to be able to use this. And I think that's kind of a key thing for the things we're going to do with this. A second example of this is Iron Mountain. And I talked about this morning, that Iron Mountain is the trusted guardian of critical data for 95% of the Fortune 1000, 1.7 trillion pieces, or 1.7 trillion pages of documents that they have stored. And we've infused now our natural language and our OCR technologies into there, such that you can get more value out of these documents. We're seeing document understanding being a trend that a lot of people want to be able to use. People want to be able to use those documents, turn it into structured data, and then make decisions based on what's in those documents. And now you're able to do that. So to sum up, well, these are the kind of the key areas that we have. The platform, which is everything from how you bring in the data to how you can actually build models on top of the data, to then the accelerators for being able to run this quickly. And there's Kaggle along with that to be able to have the community and data sets by which you can help solve these problems. Above that, there are the building blocks, the things that Google has built, and areas like sight, language, and conversation, where we've built models for you, and then now with AutoML, we have it such that you're able to customize those for your particular use case. And then finally, solutions with things like contact center and document understanding, and also our job discovery solution to make it so it's solving real business problems. And we also have been working with partners and our advanced solutions lab to make it so that we can work directly with customers and help train you, help work through your machine learning problems to make sure that we're solving your needs. So let's talk about some of the practical applications of this. And to talk about how this is being used in industry, I'd like to welcome up Stefano Pasquale, who's going to talk about how BlackRock has been using these tools to make a difference in their business. Please welcome Stefano. Thank you.
Thank you very much, Rajan, for this opportunity. I usually speak in much smaller room in conferences. And I'm here to provide to you my experience about application in machine learning, clearly in this case, application machine learning in financial modeling. I am the head of liquidity research in BlackRock. So what I do for my company, I build all the possible models that try to estimate transaction costs to trade our security in the market, trying to estimate redemption at risk, and trying to come up with a unified liquidity risk management framework that has been highly requested by regulation, but as well from business needs. We want to manage risk and generate alpha, account in a proper way for liquidity. Now, why liquidity? Liquidity is a component of risk management that has been attacked only recently for one main reason. Has a lot of problem with data, so a lot of data are not available. And the modeling of this transaction cost, redemption at risk, are very complex and depend from many features. So sparse data or very noisy data, high dimensionality, as you can guess, is a typical problem that we can try to attack with machine learning. But before going there and explaining to you our experience, provide you where we succeed, where we suffer, and what I think is still needed in the financial industries, I want to show to you, to set up the stage, I want to show to you, to do a quick interlude on machine learning in finance, just to tell to you what I mean as machine learning in finance. Okay, so first of all, machine learning, what we use machine learning for is to make sense of large volumes of data that have now become available. So what changed a lot in the last 2-3 years, a lot of data, often the structured heterogeneous data, they became available for our modeling. And trying to recognize complex patterns in the data, traditional and non-traditional data. That's what we want to do in general with the word machine learning. What machine learning is not for me is not this. We are not in an Isaac Asimov scenario, having a cyborg managing portfolio and trading stuff for us. So for us, machine learning is trying to recognize pattern in data from the market. Can be textual news, can be pricing, can be historical series of volume. And in finance, we have two very extreme use cases. Case where we have a lot of data, highly noisy, highly frequency, intraday highly frequency data, and when we want to extract signal from those data. Or the opposite, very sparse data. In fixed income, in many markets, we have only few data. So we want to be able to do a classification problem, to be able to benchmark, to be able to do benchmark in order that we can learn on a group of security where we have data and assume conclusion, analytics, and forecasting with security where we don't have any data. These are two different use cases that we face in terms of data in finance, and we are, where possible, where needed, leveraging machine learning to solve this problem. Now, be careful. When I say recognizing pattern in data, Next chart is a provocation. There is a correlation between the height of the Fed chair and the interest rate. So a machine will learn this pattern. That is not what you want to do. So in particular in finance, we are making financial decision, investment decision with our investor money to protect the portfolio from risk or to try to generate alpha. So it's very important that we know what the machine is doing. Otherwise, we can pick up a very undesirable pattern in the data that can drive to wrong decision. Just a little bit of trend, what I see happening now in my team, other team in my company, trying to investigate machine learning solution, even outside my company. I can say that there is now a big attention to time series problem. So with the LSTM, convolutional neural network, or using LSTM autoencoder, these are some experiments that my guys are doing or are thinking to do, and I see a lot of people in the financial industry focus on this type of methodology, in particular for transaction cost, for trading optimization, etc. Limitation. My big paranoia here in applying machine learning in finance is interpretability. If I build the most new incredible neural network model to teach a robot how to work in this room without smashing on the furniture and the screens, as soon that the guy knows that should avoid this obstacle, I'm fine. In finance, I'm not fine, because if I assume that I have a good model, I tell to my trader, your portfolio is becoming more risky, you should start to think to unwind your position or to liquidate slowly your position to minimize the transaction cost. The next question is going to ask me, why? And my answer now, if I use deep learning, will say, I don't know, the machine told me that, okay? So this is a very important problem. I think common to many sectors, but in finance, again, we have the fiduciary role with our investor is very important. I was very depressed since last year about the evolution of interpretability effort. I'm very happy now because I see Google itself and many people in academia really investing a lot of time and resources in trying to find solutions to improve the interpretability of the machine learning approach that we use. Now, given this premise, what we do? We collect, now, thanks God, a lot of data, a very big amount of data, internal data, public data. We move this in a gigantic repository. Data are very destructured to be cleaned, but at least now we have a lot of data points to train our model. On this, we built 4 main pillars. One is regulatory reporting that I don't want to bother you with this component. The other one is portfolio aggregation. The other one is redemption at risk. We want to try to understand if there is a risk of redemption in our portfolio. And the other one is the big topic of liquidity transaction cost. I decide that I want to trade to sell something. I want to be able to forecast how much it's going to cost me to do that. Okay? And in terms of research or production, we are pretty advanced in many of these components. And we are still in a research phase on the redemption at risk. I mention this because on the transaction cost, the problem here is, for whatever reason, portfolio rebalancing, the business decision, I want to sell this amount of this bond, this equity in the market. It's going to be expensive for me or not. It's going to be easy to do this or not. It's going to be fast for me or not. And these 2 charts are just a provocation. When I was meaning before sparse data, this is the type of data sometimes we have to deal with. In a month, for one security, we have 7, 8 observations of a couple of them. How can we train a model to do a forecast for this type of object? So we roll out in the transaction cost model. Actually, we closed last week a new model, and that I want to share with you this experience that we have to do, because we have a way to forecast the volume in the market, one component of transaction cost. And we have a random forest implementation for that, and we have a neural network implementation for that. The network, as expected, is slightly, and we didn't invest a lot of time, is slightly overperforming the random forest. But we decide to go in production with the random forest because we can have some sort of interpretability of the model. So I can tell to our trader, our portfolio manager, if there is a change in the forecast, whatever the value is, which are the features, the characteristics of the security that are driving this forecast. We are working on a narrow network approach, but I think in this case we need to do something more to do some type of interpretability. Hopefully, there are a lot of papers coming up now. We are investing a little bit of our time in this, but interpretability, in particular on trading, is a very important thing. Another hot topic because of the sparse data that I mentioned to you before, we are investigating as well transfer learning. So we try to learn characteristic of the structure of the market in a market where we have data and transfer this with market with less data, typically emerging market. So just to use some buzzword about the topic that I see internally or externally in a kind of trend of interest of people in the financial sector. This one is a very painful story of part of our experience in our research, but just give a sense about how important is interpretability, in particular the education of the senior management on relying on machine learning approach, in particular bringing the business people to be comfortable with that. So here is the other pillar that I mentioned to you before, the redemption at risk. We basically, to prove that we should use our network here because there is no better solution, we physically ran 5 models. We did the research. We knew that a stepwise regressive model would fail for such a task. We did that. We proved that fail. We moved to time series analysis, lasso regression, gradient boosting machine. We arrived to a framework where now we start to have promising number. And this one is more about we need to prove that machine learning is the solution. Sometimes machine learning is overshooting. You don't need, forget about the interpretability for 1 second, but even ignoring the problem, sometimes I can have a decent performance with a linear regression. So why to bother to involve a complex model calibration? So we had to prove step by step that going wild on the machine learning direction is really adding value. This is what this neural network does. And basically, we are trying, the blue line is a flow of a simulated yield corporate portfolio. The orange line is the probability of having outflows in this portfolio, in this case, bigger than 0.6%. And the model, as you can see, is very promising. A linear regressive model will have R square out of sample close to 0 or even negative sometimes. So totally unusable. Here we see that we are able to forecast extreme event with a very, very high quality performance. And now we are extending this to other type of fund. We're still in the research phase, but we smell something good. At least is the only model that shows some type of performance because this task is very complex. The final goal, if you remember the diagram, the temple that we moved before, we showed you before, is, okay, we build all this pillar and want to be able to include our liquidity assessment, when necessary, machine learning driven, into the portfolio optimization. So the answer we want, the question we want to give an answer is, we need to raise cash, to convert into cash part of our portfolio. We want to constrain the cost to do this, how much it's going to take, or we can play with different constraints. So we are able, we will be able, when we build the pillars, to answer this problem, including the liquidity component in the portfolio optimization. That one is our final goal. I drove you through this kind of life experience about this resource project because it's very important to what I learned myself is there are cases where machine learning can make things worse. Some cases where machine learning can is not adding particular value, just overshooting. In some cases, like the redemption model I showed you before, where proved to be the only way to go. We are personally using, in the redemption model that I showed to you before, we are using the cloud solution. This will, for the research component, was very easy for us to leverage all the benefit of having GPUs on the cloud, so we don't have to purchase GPUs, and we can expand the GPUs used for training very easily and dynamically. And this is basically what we've been doing. So, to conclude, before some closing remarks, is, again, what we are doing is, in this specific example I showed to you, transaction cost, where we have lack of data or high-frequency data, portfolio aggregation problem, we need to learn how to aggregate at the portfolio level this number, and we have high dimensionality, means the number of features that I need to include in the model that influence liquidity is huge. The redemption at risk depends as well on a lot of factors, is highly non-linear, and it's not the case that there are not a lot of paper or research on this topic. And the liquidity optimization is what I showed to you, so we want to be able to govern properly all these different components into the final portfolio construction. That's what we can include liquidity in the portfolio optimization process. What we are going to evolve this project and potentially expand in this, and I see a lot of other teams and companies evolving in this, in finance, where they show higher interest. One is infrastructure, centralized, curated, understood data hub, and this is something that is very important because a lot of young kids that we hire, super smart people in computer science, they enter, they dream to apply deep learning, machine learning, or the neural network in our modeling. They are very smart, but they ignore one thing, that 60% of their day is plumbing and cleaning data. And that's something that the more we enter in the territory of machine learning, the more this is becoming important. So having a centralized, curated, and understood data hub is very important. Cloud solution with GPUs. We're gonna be curious to to try on the TPUs, but for the moment our computational workload is still manageable with GPUs, but the more we expand the model, for sure we're gonna have experiment to do with TPUs. The improving and tune the hyperparameter search, this actually is, as you can imagine, is a very important task that we have to do in our model. Personally, I'm a strong believer of NLP, so extracting signal for textual news. So far, I didn't see yet groundbreaking solution in that, but I think that be able to extract, this is what we're going to try to work in the future, extract sentiment index about, for example, liquidity from textual news is a golden source for us in order to improve the forecasting power of our model. Am I right in that? I don't know. We're going to do the research and let you know. And the other important component is transfer learning, because in finance it's very common to have no data or very sparse data in different market, different type of asset class. So all this presentation, just to give you a sense, kind of tell you to experience on the ground how, in our specific task, we start from every aggressive model or no model, trying to enter in the world of big data, ML. In some cases, we are already using ML. In some cases, we are planning to do that, but again, only when it's necessary, and with a particular focus, sooner or later, on the interpretability component. So I thank you for the attention. I hope this testimony of the usage of machine learning cloud solution was useful for you, and I give the word back to Rajan.
Great. Thank you, Stefano. What I thought was interesting there is there are three key things to think about. One, are you using machine learning to solve the right problem? Is this something where machine learning can actually be helpful? Are you using the right data to be able to solve this in the right volume of data to actually get the right trends? And are you using the right framework to do this? It may not always be that the most accurate framework is the right thing to use. It depends on the problem. So I want to end with 5 quick lessons from what we've learned in our machine learning journey as you think about kind of areas where you can apply machine learning. So one of the tendencies, I think, is that there is a lot of hype about machine learning in terms of the kinds of things that it can do. And people think about really big things like self-driving cars and things like that. But there are 5 things that we've learned that actually have pointed us in the direction of where to use this. One thing is that oftentimes the simplest problems or the quickest problems are the ones that have the highest impact. And for us, an example of this is autofill in search. Autofill is something we probably could not live without, especially in the age of mobile. Having it such that it fills things out while you're typing is hugely productive. However, this was actually 1 or 2 engineers that put this together, tried it in the old Google Labs product more than 10 years ago, and pioneered this. And so they were able to start small and then build up something that became a staple of Google. A great example from our customers where we're doing this is Bloomberg. Bloomberg had a problem where their traders rely on a variety of news feeds from all kinds of different places. But language was always a barrier. If you're getting an article that's in Spanish, you may not be able to read that and take that into account as you're making a decision. So they use cloud translation to be able to translate news sources from many different places and provide that information and make it so that people make more informed decisions. But it was a very simple integration to make that happen. The second thing is that a lot of this is about the user experience and the problem that you're trying to solve. Google Photos is a great example of this. You know, my in-laws are able to use Google Photos. They have no idea that there's very sophisticated machine learning under the covers with this, but all they know is that all of a sudden they're able to find out every picture of their grandkids on the beach without much effort. And so oftentimes the users aren't going to care that there's machine learning. It's about how does that improve the user experience. A great example where we've seen this with the customer is Marketo, where we were able to work with them on machine learning to make their product better. Their marketers don't really have to know that there's machine learning underneath that, but they found that their product is better as a result of that and can actually do more for them. The third thing is that machine learning can open up new interfaces that weren't possible before. We've discovered this with Google Assistant. So in the Google search box, you could always have typed in questions with Google Search. However, people never really did that all that much. But opening up the voice interface has made it such that not only people are searching for keywords, but they're searching for questions, and they're actually taking actions through Google Search. So it opened up a much wider spectrum of things that we can now do with Google Search by opening up a new paradigm of speech. We're seeing this with customers. Ubisoft is a great example where they started to interact with their gamers through Dialogflow, both through chat as well as through speech, and that made it so that they could build a closer connection with their customers. And so that new paradigm made it such that it had a different business outcome. The last thing is that absolutely you should be thinking about the big thing, the self-driving car of your industry, and think about how you can transform your business with this, because I believe that every business is going to be transformed by machine learning. However, you can start small with it. A great example of this in retail, we're seeing a lot of people want to do an entire automated store, which I think is a very interesting problem to go after. How can you make the store experience better? But you could start small. You can look at shelf outs, have cameras that are trained on shelves that are looking for whether an item is there or not. It solves a huge problem with a large return on investment. However, it's something that's simple to try that gives you a stepping stone towards a large problem. So to conclude, we're really just at the beginning of this. We're providing a lot of tools out there to make your lives easier, but really this is going to be a dialogue with you. We're looking forward to working with you together to figure out how we can solve your problems, how we can make our tools better, but the more important thing is how you can make your businesses better with machine learning. So thank you for your time. We appreciate it, and have a great evening.